Let's solve the following differential equation. We will first begin by rearranging the terms and rewriting the differential equation. We have x times dy over dx that will be equals to y plus 2 times square root of y squared minus x squared. Dividing each side with x, so we have dy over dx equals to y over x plus 2 times y squared over x, y squared minus x squared divided by x. We can simplify this term as y over x plus 2 times square root of y squared minus x squared divided by x squared, such that we have y over x plus 2 times square root of y squared over x squared minus 1. So this is our differential equation which has been simplified. The reason behind this, if we consider this to be the function denoted by f of x comma y, this is a homogeneous function. The reason behind this is if we substitute the value of x with lambda x and y with lambda y, then we will get back our original function. So when this criterion is met, we call that f of x comma y is a homogeneous function. Since this is a homogeneous function, this entire differential equation is going to be a homogeneous differential equation. Now to solve this, we cannot go ahead and straight away apply the method of variable separation here. That's because our function f of x, y, this cannot be expressed as the product of two functions, so g and h, where g is a function of x only and h is only a function of y. Only when this is true, then we can use the method of variable separation. However, if we make a substitution, let's say if we make the substitution y over x is equals to some variable v, then our differential equation reduces to a variable separable form. So let's do that. So y over x equals to v is also equals to y equals to vx. Let's take the derivative on both sides with respect to x. Here we will apply the product rule. Here v is also a some function, so that means this is not treated as a constant. So we will get v plus x times dv over dx. So we'll use the substitution y equals to vx and the transform differential dy over dx written as v plus x times dv over dx and rewrite our differential equation. So this differential equation now becomes v plus x times dv over dx equals to v plus 2 times square root of, we have y squared over x squared, so that's simply v squared minus 1. Here v and v cancels out and that leaves us with x dv over dx equals to 2 times square root of v squared minus 1. Now we can separate the differentials to get dv divided by square root of v squared minus 1, which is equals to dx over x. Now what we have a separable form. Since this is a separable form, now we can integrate both sides. So let's integrate these two integrals. Now to integrate dv over square root of v squared minus 1, we are going to take the help of the integral integration dx divided by square root of x squared minus a squared from the table of integrals. So this is natural log of x plus square root of x squared minus a squared plus the constant of integration c. Now, here x is v and a here is 1. All we have to do is substitute the value of x with v and a with 1. Then the value of this integral will then be natural log of v plus square root of v squared minus 1 equals to, we missed out the 2 here, so this will be 2 times natural log of absolute value of x plus the constant of integration, which comes as a result of both the two integrals, but we're only considering one constant of integration. And since everything is in terms of log, we will take log of c, which is also a constant. Right? Now we have log of v plus square root of v squared minus 1 This will be equals to, we're going to use the property of logarithm, we will raise 2 as the power of x. So we have log of x squared, and also then this will give us log of x squared plus log of c, which can be combined to get x squared times c. Now what we'll do, we will equate the both sides, meaning we will get rid of the logarithm from both sides to get v plus square root of v squared minus 1. That will be equals to x squared times c. Now we make the substitution, y over x is equals to v. So that means we get y over x plus square root of y squared over x squared minus 1 equals to x squared times c. Or simply put, we have y plus square root of y squared minus x squared equals to x cubed times c. So this is going to be the required solution to a given differential equation.